Hello, everyone. You are welcome to the lesson on indices and logarithms. In this lesson, we are going to continue from where we left off from our previous lesson. Okay, today's lesson, basically, we are going to look at how to solve exponential equations. By exponential equations, peculiar to elective mathematics. Okay, the one that you can see in both core and elective, okay, is the situation where if you are given your exponential equation, you should be able to write both sides as a base, a common base to a particular power, then you can equate the powers and solve the resultant equation. However, if you look critically at the questions before us, okay, you can see that that is not satisfying that condition. So we are going to look at a situation that lies outside what we already know. Okay, I gave you a gist when we were looking at that aspect of the exponential equation. I told you that basically you are supposed to write the basis to be the same, then you equate the exponent. However, it is not in all situations that you can write the basis to be the same. And if you remember very well, I said that whenever you have that situation, it will require the use of log. Now we all know, okay, how to use log basically. Because when I was walking you through the exponential equation, by then we had not done log. Now we've done log, so I can introduce you to such equations. Is my point well made? Which will require the use of or the application of what? Of the law. Okay, so quickly, let's look at, okay, the question before us. We are supposed to solve the following equations. Simple equations. Okay, so A up to what? Up to E. Obviously, the one in red maybe will be for you. You do it, we go through together, or maybe you submit later. Okay, so quickly, let's go and have a look at what's the solution to the questions that we have there. So as usual, when you read a question, if possible, underline the salient part. Here, there is no salient part. Every equation usually we are asked to solve. So we don't underline any salient part. Then after that, you come and write solution, which is already written. After that, what do? You write the major question number, if any. Then you follow it up with what the sub question number again, if any. And here we have a major question number, which is 1. So we will write it. Okay, a minor question number, which is A, equally, that must be written. Then we extract. So what are we giving? We've been giving, okay, 2 to the power x is equal to 5. Okay, now, if you look at this, obviously this is an exponential equation. Do you agree with me?
Yes, please.
Very good. So once there's an exponential equation, you try your usual way. Okay, ask yourself whether what you have here, you can write both sides to have a common base to a particular power. Obviously, if you look at this, this is 5 to the power 1, 2 to the power x. There is no way you can write 2, the number 2 here to be the same base as what? 5. Again, there is no way you can write 5 to be the same base as 2. Do you agree?
Yes, please.
Okay, so when you have this, okay, this is the only and the sure way to go. Okay, what you are supposed to do is you have to bring Zacchaeus down. And you know what brings power down or powers down? What brings powers down? Log, is that not it? It is log that will bring power down. Okay, so you take log of both sides and don't write taking log of both sides. In books, they will write that because indirectly the book is trying to direct you as to what to do. So here, just directly take log of both sides. So I will take log, and usually you take the common log. So this implies that common log, okay, of what? 2 to the power x will be equal to common log, okay, of 5. Okay, so at this point, you know, this log will bring down the power, like I said. Zacchaeus must come down. So we are going to get x, okay, log, okay, 2 is equal to, so let me write it 2 well, is equal to, okay, log 5. But what are we looking for? What are we looking for in this equation? We are looking for x. Is that not it?
Yes, please.
Okay, so we are going to make x the subject here. This is one term in x. So you write it again and you divide by log 2. So both sides by log 2. So I'll write x log, okay, 2 is equal to log, okay, 5 over log 2 over log 2. Okay, so you are going to get x to be equal to, at this point, this is what you do. Okay, let me write it, but okay, you can skip this, the one that I'm going to write to the next step that will come. So x will be equal to log, okay, 5 over log 2. If you like, you can end here. This is the exact value of what? Of x. This is the exact value. But usually, we would want you to what? Approximate when it comes to what? Log. So what you are supposed to do is go to your calculator, pick your calculator, and feed your calculator with this. So find log 5 over log 2 for me. I'm waiting. Hello, I'm waiting. Hello, what did you get? Come again.
2.221.
2, oops, 2 point what?
321.
Somebody's background is noisy. If you know your background is noisy, please mute. Okay, 2 points. 3,
3219.
3, 2, 1, 1, 1, 9. Did you consider the next digit? Okay, so 1, 9. Okay, and please take notes. Yes, Ekuya.
Mr. Akman, please, when I try it, I'm getting error. I don't know what I'm doing wrong.
Okay, error for what? The log 5 over log 2.
Yes, please.
How did you feed your calculator? If you can capture it and send it to me, I will appreciate. Just
Yes,
log
please.
5. Don't the base is not there. There is a log key without the
Yes,
base. The
please.
base is 10. So just press that and see.
Yes, please.
You capture it and send it to me and let me see. Okay,
Okay.
however, I will continue. So you had 2.3219. Am I right?
Yes.
Okay, and you can see that you have approximated. Am I right? You approximated. So in maths, anytime you approximate, never forget to indicate your approximation. And your first approximation must always be 4 dp. First approximation. So that's how come you have 4 dp here. Okay, so we are going to have this. Okay, so you write in brackets, Kirsten, please mute. Okay, so you are going to have, okay, 4 dp. You indicate your approximation and you approximated to 4 dp. So usually your first approximation must be 4 dp before any convenient, okay, or required approximation. Okay, so this is what we are supposed to. 4 dp here, there is no convenient approximation, there is no required approximation, so you just conclude. So you write your therefore here. Is that clear?
Yes, please.
Okay, very good. Yes, please.
Is it always supposed to be like that?
Is it?
Always supposed to be like that? Like
Yes. Usually, yes. Usually, we will ask that you take it to 4 dp. Your first approximation must be 4
there's
dp.
nothing like there's nothing like you rounding it up like
There is nothing like
so you do it
your line
you rounding
seems
it up.
I don't really get you. Your line is a little bad. There is nothing like.
I was saying that, so there's nothing like you maybe rounding it up and making it like 3, 2 or something. But it's supposed to be like
There is nothing like 2.321.
She's asking if there's nothing like rounding up.
yeah.
Rounding up. No, you see, I said, okay, you approximate. Anytime you are approximating, okay, you have to indicate your approximation, which is 1. But for uniformity's sake, okay, we are told that anytime you are approximating, your first approximation must be 4 dp, so that we know that somebody will not take it to 1 dp, somebody will not take it to 2 dp, and what have you. It makes marking difficult. So for uniformity, we'll tell you that your first approximation must be 4 dp. Anytime you approximate, must be 4 dp. That is, if what your dps that you have there is more than 4, and you are approximating, it should be 4 dp. However, if it's less than 4, you should write exactly the less than 4. So in actual fact, if the whole of this gave us 2.32, would have written 2.32 there. Is that clear? But if it is more than 4 dp and you are approximating, you approximate to 4 dp. And sometimes when you approximate, like I was saying, okay, even the next question, maybe I would ram home my points better. Okay, there will be a required approximation. Here, there is no required approximation, so I've taken it to 4 dp. If there is a required approximation, then I will now take it to what the required approximation. So your first approximation 4 dp before required or convenient. Sometimes it becomes necessary for us to deal with a convenient approximation, especially when you are dealing with points where you are going to plot. Okay, you can see that if maybe my S coordinate gave me this, S coordinate is this, how would you plot 4 dp? If you can plot 4 dp, then it means maybe you are a calculator, a graphical calculator. Okay, it is easier to plot 1 dp than 2 dp, 3 dp, and what have you. So in that situation, your convenient approximation would be 1 dp, because you know you are going to plot. You get it? You will take it to your 1 dp or maybe 2 dp approximation, but not beyond that. Is my point well made? Okay. All right. Is Mama, Prof. The issue is the programming of your calculator. The numerator, the 5, should have been in brackets. So put it in brackets and press equal to, and you thank me later.
Yes, please.
All right. Okay. So check if it will work. So that's why you need to read your manual. Every calculator needs programming. The ash one, okay, the old one, okay, the one before this one, that one, okay, this problem will not come. But the new one, that's how it's programmed. So please read your calculator manuals, okay, before you start using it as your manual.
Thank
You are welcome. Okay, so that will be it for A. Let's go and look at that of the B. Please, are we all fine?
Yes, please.
So here we didn't do anything special. We said when you cannot write it as a base on each side, a common base to a power, just use log, apply log. Okay, and the rest will be calculator work. Okay, so B. Okay, what are we going to do? Is the same technique. What are we giving? We've been giving, okay, 3 to the power x is equal to 5. You can write, okay, this to be a base 3 to a certain power. So in this case, if it was 1, we could have written 3 to the power 0. Okay, so in this case, what do? We take log of both sides. So this implies that log, common log, not log to any base. Okay, common log of 3 to the power x will be equal to common log, which is log to the base 10. And you don't write the 10. Okay, so now that doesn't mean if you write a 10, okay, we will mark you down. What without a 10 can do? Okay, I mean, with a 10 can do, without a 10 can also do, and we'll write less. So now what do? We'll bring down our x. Okay, and we get log, okay, 3 is equal to log 5. My professors, are you following?
Yes,
Okay,
please.
so you write it again before you divide. Never forget this. Okay, so over log 3. Okay, over log 3. Okay, so this will cancel. So you get x to be equal to what? Log, okay, 5 over log 3. Okay, I should have skipped this and maybe approximated straight away. So now, therefore, my x will be equal to, give me the approximation, over log 3. Okay, give me the approximation. Log 5 over log 3. Okay, Equia, I'm relying on you.
1.4649.
1.4649.
649.
I hope you consider the next digit to approximate this.
Then it's 1.46.
1.46 what?
50.
50. So when we are approximating, be careful. As for you've done this. The DP approximation significance figures. That's why you did it in Form 1. So that when it comes to its application, you know how to deal with it. So in fact, the way you said this, I'm doubting whether you did the right thing here. Is that the right thing that is here?
Yes, please.
Okay, so this one will give us 50. Am I right?
Yes, please.
So don't just write the 4 digits. You know how to approximate, please. Okay, JHS, okay, and SHS, we reinforce that. Okay, Racy.
Okay, Mr. Hackman. So if the way this one, the approximation will be, when you approximate the one with the 9, you have to move it and then another one will become, I think 5 again or something. So can you decide to write like the entire figure that you got over there?
No, it will waste your time.
It's again.
It will waste your time. That's the more reason why I want you to approximate. When you see a whole lot of decimals there, okay, it is not necessary to write the whole of. Even your calculator has truncated it because your calculator equally can take a certain number of digits. I don't know if you get my point. So we are saying that when you also want to reduce that stress, okay, but you are reducing that stress, reduce it using 4DP. That's all.
Okay.
Okay, is that clear now?
Yes, sir, thank you.
Okay, so now your 4DP, you said that will give us 50. But anytime you approximate, don't forget to indicate your approximation. Otherwise, because if you write this, in actual fact, you can see that x is equal to this and some other stories that you decided not to be interested in. So the equal to is a very sensitive sign. If you write this and you don't write 4DP, then you are saying that this is exactly equal to this. Meanwhile, that is not so. This is an approximated value of this because you truncated, okay, what you have there, the decimals at a point. All correct?
Yes, we know.
Okay, very good. So this will be it for, okay, B. Okay, so any questions? My professors, any questions? Are we all fine? Okay, we thank God. Okay, now C will be yours. You try later because of time. Let's go and look at D, another special situation. Okay, and with that concept, you can also do the E. Then we move on to our next set of questions. Okay, if after going through all that we are supposed to do, if we have time, maybe I will ask you to do it and we all come and mark it together. So quickly, let's move on to the E. Okay, sorry, the D. So D. Okay, what are we giving? We've been giving 2 to the power x is equal to what? -2. Am I right?
Yes, please.
Okay, very good. All right, can we write what we have there? Okay, to have the same base to a power. Let me see whether you fall victim.
No, please.
Okay, so please take note. Anytime you have any number to a power and it's equal to a negative result, okay, automatically there is no way you can raise a positive number to any power to get a negative number. No. I hope you get my point. Hello, are you with me? There is no way you raise a positive number to any power to get negative. No. If you can give me such an example, okay, then I will ask you to teach. Because I cannot. So on that note, this is what we do. It's the same connection. Okay, however, as you mature, straight away you can conclude from here. But okay, I'm assuming we are not mature. So once you cannot, we are using the same technique. What do? We have to take log of both sides. So it will be log, okay, to the base 10 of 2 to the power x is equal to log, okay, of what? Minus 2. So you bring your x down. I just want you to know something. Otherwise, I wouldn't have done this. Okay, 2 is equal to log, okay, negative 2. So obviously, because you knew from the beginning that you are going to take log of both sides, and you know this side is negative. Do we have log of negative numbers?
No, please.
Okay, so it means here, if you continue at a point, you know that your calculator will give you math error. And it will not be the QSK math error. A QSK math error was wrong input. Okay, so this one will be actual math error. So in this case, okay, what you write, because you were just asked to solve, like I said, what do you write? No solution. Is that clear?
Yes, please.
Okay, if we're asked to find the true set, then you write therefore empty set. You remember? Yeah, you were asked to solve. So you write your conclusion, therefore no solution. Amma.
Mr. Ackman, so please, the one that will make X stand alone and send 2 to the other side, we don't apply it here.
Which one? Writing it again and dividing it by log 2?
No, like the question, 2 raised to the power x equal to negative 2. Then write x is equal to log, like, then 2, I don't even know what I'm saying.
No, I don't really get you. Come again. I want to
Actually,
write
it's
what you
fine.
are saying.
It's fine. There's
It's
no
fine.
basis.
Okay, there's
Yeah.
no, all right. Okay, all right. Okay, we thank God. All right, okay, so this will be it. So I'm saying that as you mature, immediately you see that there is, okay, a negative here. And even if you proceed, this will be the first step, log, but you know that you are taking log of negative. So at this point, don't go beyond, just write no solution. Or even at this point where you know that there is negative here, you can write no solution there. So if you look at the E, okay, 4 to a certain power is giving me negative. So straight away, I will know that no solution. Or if you want to convince us, okay, how you got your no solution, then you have to take log of both sides. And you know that you take log of negative here. And because the side will give you math error, it will give you no solution. All correct?
Yes.
Okay, very good. All right, Inshira.
Please, you're saying that the truth sets can be no solution. Please, do you mind writing it for me to see?
Oh, the true set will be, I didn't say the true set will be no solution. No. Were you in class yesterday?
For some.
So it means you didn't watch the video as well. Okay, because if you are asked to find the true set and you are unable to get any x value, or maybe your equation is in x, okay, that will make your equation valid. Your conclusion will be an empty set. So you conclude this way. Therefore, then this is an empty set. There is no such x. Is that clear?
Okay. Thank
Okay.
you.
You are welcome. Okay. So next time I won't. I will ask you to go and watch the video. I think you charmed me. I will usually not do this. All right. Okay. So this is what we have. If you are fine, then it means we can move on, Abby. Okay. So indirectly, I've done the E for you. Okay. So let's move on to our next set of questions. Okay. So this is what we have. You can see that a little more bone. Okay, initially the one that you were working with, the equation, yes, the example 1, you saw that your exponent, just one term exponent. Let's go back and see. One term exponent. One term exponent. So monomial exponent. However, this time around, we have a binomial exponent. How do you deal with such a situation. And remember, I've told you, you know my style. I will give you all the possible situations. Okay, so that I know that any question that comes in the exams, you are fully insured and covered. All right, so let's go and look at the solution to this one. Okay, quickly, our next page. Okay, so solution, again, let's read the question and see if there is any salient part. Do you see any salient part in this question? They are asked to solve the following equations, then correct your answers to 2 decimal places. Any salient information that we are supposed to underline?
Yes, please.
Which is?
Yes, please.
2 decimal places.
Perfect. All right. Anytime you are asked to approximate, okay, be very careful. So you underline 2 dp. Okay, nowadays, for you not to even say that you didn't see, usually in questions, they will make a 2 decimal places bold. Okay, so in that way, it means the question has underlined it for you or has made it salient for you. Okay, very important for you to take note. So if you fail to do that, then it means, if your answer in that form, then it means you are just careless, sort of. Okay, Karen.
Mr. Hackman, are we done with
Are we done with what?
rational function?
Yes, we are done. The last, what do you call it? Assignment that you were given, we were supposed to discuss, but I said, because of my target today, I've sent the solution to the platform. You can check.
Yeah.
It's there. So
the
you watch
solution.
and use it to
Yeah.
correct yourself if
Okay.
necessary. Okay. All right.
Okay.
You're welcome. Okay. So now that was just by the way. So let's continue with the solution. After underlining the salient parts, now we come and write solution. Then we write the major question number. There is 2. Okay. Then there is minor, which is A. Okay. So what are we giving here? We are giving 2 to the power x plus 2. So x plus 2 is the exponent, is equal to what? 5. Again, there is no way we can write the basis to be the same. So what do? We take log of both sides and common log. So log, okay, to the base 10. You don't write it of what? 2 to the power x plus 2. And that will be equal to log, okay, 5. So with this one, the whole of the exponent will come down. Am I right?
Yes, please.
Okay, so it will be x plus 2 log, okay, 2 is equal to log 5. Do you see anything wrong with what I have written?
Yes, please.
Okay, what is wrong?
The x plus 2 is supposed to be in brackets.
Perfect. Okay, it's because your exponent is binomial, if you are bringing it down, make sure you bring it down in brackets. Is that clear?
Yes, please.
Okay, very good. All right, so at this point, you are in a very comfortable lead. Okay, one way you can expand and later make S the subject. That's what I'm going to do. Another way is to divide by this. If you divide by this, you are going to get S plus 2. Then you move the 2 to the other side. Is that clear?
Yes, please.
Okay, so let's expand and see what will happen. So you know this one, you can expand. Okay, so it will be x times this, which is giving us what? X log 2. Then 2 times this, which will give us plus 2 log 2. All correct? And that is equal to log 5. Okay, so in effect, I'm looking for I'm looking for x. So the term in x must stay or must be isolated, and the other terms on the other side. So I'm going to isolate my x log 2, which will be equal to log 5 minus, please, are you following? 2 log 2.
Yes, please.
Okay, so at this point, what do? We divide through by what? By log 2. Okay, but what I'm going to do is I'm going to divide the whole of this by log 2. So it's like I'm considering the whole of this as a term. So in that case, I need to write it again. However, if you are going to write this over log 2, this over log 2, this over log 2, okay, you know you can choose not to write it again. But you know every fraction, it is better left in its single fraction form. So in that case, that will inform that decision for me to write it again before dividing, because I'm dividing the entire thing by log. Okay. All right, Karen.
Mr. Hackman,
Oh, yes, I'm listening.
okay, I don't know if this question should be asked, but I so far understand what you are doing. I just don't understand why you are doing two logs on different sides.
Why
Because
I am
when I
what?
want to doing two logs at different sides.
Why should I
So
bring
I
2
want to
logs? Are you talking about here?
know at the beginning I understand all that you are doing, but then I don't understand why.
Why? I also don't understand why your why. So complete your why. I don't know whether it's your network. Nanekia.
Mr. Akman, please, I don't understand from the the third step.
Okay, this is the first step. Second step here.
Yes, please.
Okay, so you know, it's just like AB times log this. If you have log of, okay, if you have log of, let me put it this way, log of A plus B, then you cannot expand and write this as log A plus log B. That one will be wrong. But if I have AB times log of anything, okay, if my AB is a coefficient, then it means it will be A times this and B times that. You get the point?
No, please.
But I'm sorry,
Oh,
my light is
assuming log A is X, and I have this, how would you expand this?
AX plus BX.
Okay, so is it not the same?
Yes, please.
Afa.
Yes, please.
All right. Okay, Ishira.
Mr. Hackman, please, what if before the first step, you break it to 2 raised to the power x plus 2 raised to the power 2, so that
It will not be plus if you break it down that way. If I were close to you, I would have given you a knock.
times.
But then you have received the knock already. All right. Okay. So it's supposed to be times, but I'm saying you don't do that. Okay. Don't do that when you realize that you cannot write the basis to be the same. So here, per experience, we know we take the log of both sides. Where you can write the basis to be the same and you have this situation, we will come to that, how to deal with it. And you will go your route, what you just said.
Okay.
All right. Okay, very good. Okay. So are we good to go now? Okay, so
yes,
it means your X will be equal to your calculator work. So I'm waiting for, feed your calculator with this and give me the answer, but give me 4 DP. Hey, Karen.
Please,
Mr. Hackman, can you hear me?
Come again.
Can you hear me?
Yeah, it's better now.
Okay. I said that is it because of the x plus two? That's why you're using both two logs at different sides.
Is it because of what?
The x plus two, like the power from the question. That's why you're using log at both sides.
Which step are you talking about?
The beginning step, like the first step.
This one. This step.
Yes.
So we said the bases are not, you cannot write the basis to be the same. And we now know that if you can write both sides to have a common base to a particular power for you to equate the powers, okay, what do? You take log of both sides.
Okay.
So that's all that we are doing. You get it? I guess you
Yes,
you joined us late, right?
yeah.
Okay, so that's why you are taking us back. All right. Okay, so that will be it. So then we move on. So now here I'm waiting for your answers.
Please we ask for 4 dp or 2 dp.
You said what?
Did we ask for 4 dp or 2 dp?
Oh, you remember I said something? No? I said anytime you are approximating, your first approximation should be
Okay, 4 dp, yes, please. Okay,
before.
So yes, okay.
Okay, first approximation, I'm
Please,
waiting.
it's
0.19.
0.3219.
And you indicate your approximation, which is what? 4 dp. Okay, now I've written there for 4 dp here. Can I conclude with a 4 dp?
No.
No, because there is a required approximation. You get the point. The other one, I concluded with a 4 dp at that stage because there was no required approximation. Okay, so it means that therefore cannot be here. Take note. Am I clear? Okay,
Yes,
so I'm now going to draw my conclusion with the required approximation. So this time around, there is a required approximation. You cannot end with what the approximated value that you have here. So I write therefore x is equal to, we are looking for 2 dp. So that will give us 0.32, and you put in bracket 2 dp. All correct?
Yes, please.
Okay. Afa, are we all fine?
Yes, please.
Okay, so we are going to do, okay, maybe, I think maybe 2 more. Let me see, or if not more than 2. Okay, so quickly, let's go and look at that of the B. Okay, the B crowd will be similar. So I will skip the B. Okay, let's look at the C. The C has, okay, the exponent contains negative. So the B, if you're able to do this, you should be able to do the B. Okay, quickly, let's look at the C, the solution to C. Okay, C, what are we giving? Oh, sorry, forgive me. Remember I said, okay, we could have divided through straight away by log 2. So let's look at it from that approach and see which one will be ideal. So that next time when you encounter such a situation, you know that that will be the best option, okay, on the table. So now, odds. Okay, by that, what I mean is we are going to continue from here. So we've done everything there, okay, up to giving up to what? Up to this stage. Your x plus 2, okay, in brackets, then log 2. Okay, is equal to what? Log 5. Is my point well made?
Yes, please.
Okay, so at this point, one term here, one term here. So you are supposed to write it again, then we divide. So you have a variable, okay, factor multiplying a constant factor, okay, and you can always divide by the constant factor. So over log 2, over log 2. Okay, so at this point, we are going to get x plus 2, okay, is equal to log, don't approximate now, over log 2. Okay, but what are we looking for? We are looking for x. So x will be equal to, what do? You move this one to that side, so log 2, forgive me. So you are going to get log, okay, 5 over log 2, then minus 2, all correct.
Yes, please.
Okay, so if you like, you can write this as a single fraction, but it's not necessary. Your calculator, this is relative math, your calculator can give you this value. And if you check, your calculator equally will give you the same value as this. Okay, and it's the same thing. Because if you can see that what I have here is a single fraction form of this. If I separate this, it will give me log 5 over log 2. Then I'll get 2 log 2 over log 2. The log 2 will cancel, so I'll be left with 2. So it's the same thing. You get it?
yes, please.
Okay, so that gives us what? The 0.3, okay, 219, okay, the 4 dp approximation before you take it to the required approximation. Therefore, x is equal to 0.32. Okay, and it will be your 2 dp. You get it? So either way will be fine. Okay, so which way do you want to go?
The second one.
The second one. All right.
The
Okay.
first one.
All right. So it is your way. So take that route. But I will usually, okay, because it's going to be calculator work. Okay, I will go for this. Straight away, I will divide without expanding. Okay, then I will move. Then the rest will be calculator work. Okay, so take note of that. Okay, so that would be it for, so I'm left with, okay, I think I didn't do the C. So I'm now going to do the C, or we are now going to do the C. Okay, C, what are we giving? We are giving 2 to the power 2, sorry, x minus 1. Okay, is equal to what? 5 to the power x. The same concept. Ah, okay, I skipped the B. So I said if you're able to do the A, sorry, yes, you should be able to do the B. So C, this is what we have. So at this point, can we write the basis to be the same? Can we? No. Okay. So if that's the case, then we know what to do. Okay, what do? We take log of both sides. And we are going to have log, okay, 2 to the power x minus 1 is equal to, okay, log, okay, 5 to the power x. And you can see that unlike the first two, where you had only, okay, one side having an exponent containing x, here both sides, okay, has x. So what do? The x here minus 1 will come down. This will also come down. So I'm going to get x minus 1, because here it is a binomial, I put it in bracket. Then my log 2 will come. All correct. And here will be equal to x log 5, sorry. Oh, let me clear it and write it neatly. My professors, are you following?
Yes.
If you take log, it will bring the exponent down. So x log, okay, 5. So this is what we have. And again, what do? We are going to expand. You cannot divide, okay, here, because you can see this side doesn't contain only a constant. It has a variable. So the expansion will always be, okay, the situation to go here. So to avoid all confusion, okay, please take note. Okay, remember I said I usually will use, okay, the other one that I will divide, and I will do that when I realize that this side contains only a constant, no variable. If it contains a variable, then you are compelled to expand, combine like 10, then later, okay, deal with it. So in this case, what do I do? Yes, please. I said, okay, I said now, because of the situation here, okay, with this one, what we are going to do is, okay, with this one, this side contained only, okay, a constant. So if I have a constant here and I divide by a constant, it will also give me a constant. Okay, so I'm not worried. That's why we divided straight away. Okay, so that is allowed. And we know that we can expand as well. But with this one, our first approach, which will be, okay, dividing both sides by log 2, will not work because this contains a variable. Because if I have x, okay, times this will give me a variable. X times 2 will give me 2x. It's a variable term. Is that clear?
Yes.
So in that case, you don't divide, expand. And I'm saying that because of that, I am going to tell you to go the expansion direction. Okay, anytime you encounter, okay, such a situation, always use the expansion, because you know that the other method has its shortfall. You can only use it when the side, okay, contains only a constant. But your expansion one, okay, will work for this one as well. So we will go for the expansion one, whether the side contains only a constant or not. You get it?
Yes.
Okay, great. So now the expansion approach, we are going to expand. So this will mean x times this to give you x log, okay, 2. Then minus 1 times this, which will give us minus log, okay, 2. Okay, and it's equal to x, okay, log 5. So at this point, we have 2 terms in x. Am I right?
Yes.
Okay,
Yes.
so we are making x the subject. So we have to collect these two terms on one side. So it means we are going to move. Okay, and remember I told you, anytime you are moving, it becomes necessary maybe, okay, your variables that you are looking for, one is on each side, and you are moving. What is the advice? What
You have
advice?
to make the log positive. Move the negative one to make it positive.
All of them are positive.
You have to check whether what you move wouldn't bring a negative number.
Not quite, okay, not quite exactly what I said, but I think you have an inkling to what I'm looking for. Okay, any other?
Negatives.
You avoid negative, not exactly so. Oh, remember I said, hello, you move in such a way that your movement will involve less negative terms. You remember?
Yes, please.
That's what I said. So if I move this one here, assuming I do my normal movement, okay, this will be positive. This will now come and be negative. This will come here. This will also be positive. So that movement will give me only one negative term, true or false? True. Now let's see if I move this one to this side. If I move this one to this side, this will become negative. Already I have a negative term here. Can you see? So how many
Yes,
terms will
please.
be involved? Negative terms will be involved. 2 in that situation. So it means it will be appropriate, ideal for us to move this one to the side because that will involve only one negative term. So what do? We maintain our x log 2 here, bring this one here, which is minus x log, okay, 5. And that should be equal to this one will come here and become positive log 2. All correct?
Yes, please.
Okay, very good. So at this point, you know you are looking for x. So what do? You factor out x. All correct? So you'll be left with log 2 minus log 5. Okay, is equal to log, okay, 2. So you write it again before you divide. Don't forget. My professors, are you following?
Yes.
Yes, please.
Okay, so over, okay, log 2 minus log 5 over log 2 minus log 5. Okay, so x will be equal to, we are matured. So feed your calculator with this. Come and approximate it and write it there. 4 dp, I'm waiting. So do log 2 over log 2 minus log 5. My professors, I'm waiting. This is just calculator work. Don't let us waste time.
Negative
Negative
0.7565.
plus 5. I hope you've done the right 4 dp approximation. So 4 dp.
Yes.
Now I don't trust you like that. Okay. So this will give us what we have here. However, there is a required approximation to dp. So that's where we draw our conclusion. S is equal to minus 0.76 dp. All correct.
Yes, please.
Okay, very good. Okay, so that will be it for the C. Okay, maybe we are going to do the D together, and as a guide, you later use that to do, okay, the E. All right. So if you don't have any question, then let's look at that of the E. Okay, E, what are we giving? We've been giving 3 to the power x plus 2 is equal to 5 to the power x minus 1. Okay, Matilda.
Mr. Hackman.
Mr. Ackman, please can you hear me?
Yeah, I can hear you very well.
Please, I'm also getting math error
For which one?
for the log 2 over log 2 minus log 5.
Okay, so please capture it and send it to me. You should have said, Mr. Ackman, I also want to use you as my manual. Then I will know. Anyway, so send it to me and let me see what went wrong. Is that okay? So capture your screen and send it to me. I can diagnose what went
Thank you.
wrong. All right. Okay. Okay. So whilst I'm waiting for her. Yes.
It is D.
It is D. Okay.
Yes,
Thank you. So at this point, I was solving my own question. Okay. Thanks for drawing my attention to that. Okay. So,
You're welcome.
all right. Okay. So now what do we do? This implies that, okay, now we take, because we know we cannot write the basics to be the same. And we know anytime we can't do that, it means we have to use log. Okay, so without thinking, we go and take log of both sides. Okay, a binomial exponent, so we put it in bracket. Very important. Okay, then your log 3. When you bring it down, put it in bracket. Again, this side to a binomial exponent, so you put it in bracket. Afa. Okay, so
Yes, please.
we said whenever you bring it down, we are now, yes, please, you sent it to me.
It's log 3, not log 5.
Which one? Hey, what is happening?
Yeah.
I'm exhibiting symptoms early. All right. Okay, so this is what we have. Thanks for the correction once again. So now this is what we have. And I said we have agreed anytime we encounter such a situation, okay, whether the side is a constant or not, we will expand. So we are going to expand. So x log 3 plus 2 log 3 will be equal to x log 5. Okay, then minus log 5. Am I right? Okay, so we are looking for x. So we collect the terms in x on one side. Again, we are going to move. So let's look at the appropriate movement. So if I bring this one here, this will be negative. I will have one negative term here. And if I move this one here, this is already negative. This will also come and give me negative. So I will get 3 negative terms. Is that clear?
Yes, please.
So now let me see the other movement. If I maintain this and move this one to the side, this will now be negative. And move this one to this side, this will be positive. So I will have only one negative term in that situation. Is that clear?
Yes, please.
So it means it will be ideal we move this one to that side. Safa. Okay, so that's what we are going to do. So we said we are going to maintain this and move this one so that we'll move. So we are going to get, okay, let me bring this one here. 2 log, so this will be maintained here. 3. This will come and give you plus log, okay, 5. And that will be equal to this will be here, which is x, okay, log 5. Then this will come minus x, okay, log 3. Okay, so now this side we can factor out x. So I'm going to write this side first, but factorizing. So I'll have x, okay, in brackets log 5 minus log 3. Okay, it's equal to, this side will be maintained just as we have it over there. So 2 log 3 plus log 5. Okay, so at this point, what do? I write it again before I divide. So x, okay, log, in brackets, log 5 minus log, okay, 3 will be equal to 2 log, okay, 3 plus log of 5. Okay, so over log, okay, 5 minus log 3 over log 5 minus log 3. Okay, so in this case, we are going to get S to be equal to, I'm waiting for the approximation, the 4 dp approximation. Okay, let me see whether Matilda has sent. Okay, the photo. And so I'm waiting. Okay, so Matilda, your denominator, the log. Okay, I can see the log in a box, the L in a box. What happened? Okay, that is 1. Then 2, the log 2, the first log 2 in the denominator. After the 2, you have to bring brackets. And after the 5, you have to also bring brackets.
Mr. Hartman,
Yes, please.
please, I did that. I also got math error.
He said what?
I first did that and I got math.
You did what later? You
I
put the 2 in
did that.
brackets and the 5 also in brackets.
Yes, please.
And I'm saying that you can see that your L is in a box. Can you see?
No, please.
Your L shouldn't be in a box. That's what I'm seeing on the screen. Your L is in the box for the first log 2 in the denominator. Okay. If maybe my age, I'm sending it to the platform. Okay, so that people will see whether indeed what I'm saying is right or wrong.
Yes, please.
Okay. Please, okay, I have something on the platform. Check. Okay, whether the first L in the denominator is not appearing in the box. Okay, so I'm waiting for the answer here. Once some of you will check for me. What do we have?
Please, 7.4520.
7.4.
520.
520. Okay, 4 dp. Okay, so therefore, x is equal to 7.45, and that will be 2 dp, the required approximation. All correct?
Hackman.
Okay.
Hackman.
Yes, please.
Is the Keza, it's not a box.
Is the cursor not?
And I think maybe she tries closing the brackets.
If you
Maybe
want.
it will work. If she closes the bracket, see like
Which bracket?
It's like when check the calculator. The denominator side, the log 2. The bracket is not closed. And then
Yes, that's what I told her. The 2 brackets should close, then 5(2) should close. But she said she has done that.
A.
But the numerator too, I
Okay.
can't see it. What is the light? Please, if you can give me a better picture, because the numerator, I can't see what is there for me to see whether there is any issue with the numerator as well. Okay, but once she's working on that, and later she will read her manual. Okay, let's continue. Okay, so let's continue. So we are done with this. Okay, set of questions. So we are going for our water break. Okay, then maybe I will see if I can take, okay, or grab that opportunity to deal with her issue, the calculator issue. Okay, so welcome back from the water break. Now let's look at our next set of examples. So example 3. Example 3, we are supposed to solve the following equations. Okay, solve the following equation. And you can see that this time around, okay, the nature is quite different from what we've done so far. And once again, this is peculiar to elective maths. Okay, so quickly, let's see how best we can break the question down here for us to solve. Okay, so easy. You like it. Believe me, you. All right, so as usual, when you read questions, salient part you underline. There is no salient part here. Every equation you are asked to solve usually. Okay, then the question number should come. Okay, then you extract what you are given. So what are we giving? The sub question number is A. So you've been given, okay, 2 to the power 2x minus 3 to the power 2x. Okay, then plus 2 is equal to 0. Oops. So let me clear that and write the equal to well. Okay, so it's equal to 0. Please take notes. Okay, this is what we have. Okay, so this is it. This equation that you have there obviously is also an exponential equation. But anytime you have an exponential equation, okay, check whether the exponential equation or the terms, you can write it as 2 to a certain power x, as you can see there. Or maybe all the terms, you can write it as, okay, a base to a common power. But you know that if it is a base to a common power, okay, and the terms are not alike, you cannot add. Because if I have a to the power, let me say a to the power x plus, okay, let me use a, plus b to a to the power y. Can I say that this is a to the power x plus y?
No.
No, I cannot. However, if I have a to the power x, okay, plus maybe 2a to the power x, I know that these two are like terms, so I can add and write 3a to the power x. Is that clear?
Yes.
Okay, so if they are not like terms, you cannot do this, and you can't do what we have here too. So we are going to look at the best way, okay, to deal with questions of this sort. Now, if you look at this, you can see that this is an equation in 2 to the power x. Okay, the power of x, the least will be x here, but here it will be 2 to the power 2x. So this is bigger than this. Hello, Karen.
Mr. Hackman,
Yes, please.
please can't you multiply the 3 times the 2x to get 6x, then you change it
Which
to a
one? You
common base?
multiply which one?
The 3 there times the 2x, right? Then you get 6x.
Which 3?
This 3 here
The 3 here, you multiply.
by the 2x, then you get 6x. Then you reduce it to, like, you take it to a
Karen,
common
Karen,
Mr.
Karen,
Hackman.
how many
Mr.
times
Hackman,
did I call you?
3 times.
All right, one thing I like about you is you ask questions. Okay, keep it up. Okay, but please take note. Okay, I know as for this error, we've gone beyond that. Okay, the power here, until it is 1, you cannot multiply, okay, your coefficients by it. Because if I have 2 squared times 2, okay, this is not the same as 4 squared, and it's obvious. Until you deal with the power, you can't come to the coefficients and remove the bracket. All correct?
Okay, I understand.
So you can't do that. Immediately you do that, okay, then okay, obviously they will know that you were not my student.
Okay.
All right,
Thank
so
you.
you can't do that. You cannot do that. Okay, so
Because
in this case, this is yes, because if the power here was definite, okay, and you can, maybe it was 3, I have to deal with the power, which will give me 8 before I come and multiply it by 3. Okay, all right, but that's just by the way. So now this is what we have. So what we are going to do is all the terms that contains 2 to a certain power, and you can see x in it. You want to write it in this form, 2 to the power x. Okay, by that, this is what we mean. Remember when we were doing, okay, the core math situation where you are given an exponential equation in one variable and you are asked to express another expression in, okay, that variable. You remember, we have to break this one down. So we know when we're breaking that one, we said there are 2 ways. We can write that one as 2 to the power 2x. As one way of writing this is 2 squared all to the power x, you remember. And we said another way is to write it as 2 to the power x all squared. Is that clear? Do you remember? They mean the same thing. However, for convenience sake, okay, we are going to write this one again in this form, just as we did in that situation. So I'm going to write this one as this implies that, okay, 2 to the power x all squared minus 3 into 2 to the power x, okay, plus 2 is equal to 0. Now, this is all that you are supposed to do. If you look at the resultant equation critically, you will see that you have a quadratic equation in 2 to the power x. Because you can see 2 to the power x, the highest power here is what? 2. Can you see? Okay, however, this quadratic equation here is not friendly to you. Okay, but we can take it home, and this is what we are going to do. Okay, so we will write, let any variable of your choice apart from x be equal to your 2 to the power x. Okay, so in this case, I'm going to write y be equal to what? 2 to the power x. So if that's the case, then this will imply that this is y, so that will give us y squared minus 3y plus 2 is equal to 0. So now this quadratic equation here, you can relate with it very well. Is that not it? Okay,
Yes.
so we are going to solve for y in this resultant quadratic equation. So we have to, the coefficient here, leading coefficient is 1. We thank God, so we have to only consider the factor pair of what? Yes, please.
Please come in.
From where?
From the third one.
From the first step, this one.
Second.
This one.
No, please, the one
This one. This is not a second step. This is just the first. So this is the first step.
Okay, yes, please, yes.
Okay, I said, okay, anytime you are going to, you can see 2 to the power x. So obviously, it's trying to give us an information that, okay, what you have here is an equation in 2 to the power x. So any power that involves x there, check whether you can write it also as 2 to the power x, it's corresponding. So this one contains x there, but we can write this one as, I said, we have 2 ways. We've done this, how to write this. Okay, call math situation. There was a particular situation which required us to do this. And we said we can write this one as 2 to the power x squared, or 2 to the power 2 squared, or 2 to the power x. From indices, you know, this will expand and give you, the exponent will multiply. So it will give you 2 to the power 2x, which is what we have here. This will also give you 2 to the power 2x, which is what we have here. So it's the same. We are applying what you already know, you've been taught. So we don't have to go back. You just have to apply. And remember, I've told you, anytime I move on, okay, if there is any concept that you've not been taught, I will tell you. But once you've been taught, I expect you to apply it at that point. So it means I'm replacing this one by this, so that I will have 2 to the power x there. By 2 to the power x all squared. And that will give me the same. So what I have here is another form of writing this, but for convenience, then you let your y, any variable of your choice, apart from x, be equal to your 2 to the power x. So now we've landed here. We are going to solve. So constant here, 2. Factors of positive 2, which when you multiply, you get positive 2. When you add, you get negative 3. Will be negative 2 and negative 1. Am I right?
Yes.
So I will split this one using the factor pair. So y squared, okay, minus y, then minus 2y, or someone can write minus 2y minus 5, the same, then plus 2 is equal to 0. So now we are going to factorize by grouping. And you know, okay, what do we do? Don't use bracket to indicate your grouping. It can put you in trouble. Group the first 2 mentally and factorize. So y out, y minus 1. Okay, last 2 mentally and factorize. Minus 2 out, y minus 1. And it's equal to 0. So at this point, I'm going to get y minus 2 into what? Okay, y minus 1 is equal to 0. So you come and set each of the factors here to 0 and solve y. So y minus 2 is equal to 0, or y minus 1 is equal to 0. This connector is very, very important. You cannot, again, I'm repeating, you cannot use comma. You can't use n. Okay, if the product of 2 numbers give you 0, then we are going to look at least one of the numbers should be 0. So either this is 0 or that is 0. Either goes with or, not n. So you come and solve for your y here. It will be 2. Your y here will be 1. Is that clear? Can I say, therefore, y is equal to 2 and y is equal to 1? Or y is equal to 1? Can I conclude?
No.
You cannot conclude with what you introduce, remember. You can't conclude with y. So y at this point accept its usefulness, or outlive its usefulness. So you are going to substitute back. Okay, it was just for convenience sake. So at this point, I'll write, this implies that, remember you said y is 2 to the power x. So it means 2 to the power x here is equal to 2. Or 2 to the power x here is equal to 1. Is that clear?
Yes.
Please, who wants me to come again? Okay, don't wait for me to ask this question. Okay, it doesn't always come. I know usually it's part of me, but it will not always come. Okay, Karen, where lies your issue?
I wanted to know, like, can they give you an instance where you have to substitute back into the equation? So you have to put all the values that you found for 2x back and see which one, like, fits the equation.
No, are you talking about, is there a situation where you can what? Substitute?
It's like, you see, when we're treating one of the two radical equations.
No, you were talking about the log equation.
Yeah, I was saying that, would they give you a situation where they'll ask you to substitute what you found for 2x into the given equation there to see which one?
At the normal situation, okay, if you are given any equation and you solve, you are supposed to test whether the values there are right. That is for you to be sure. However, if you are dealing with normal equation and you do the right thing, automatically the values that you get will satisfy. Unless you are dealing with special situation, which would be radical equations or Sedic equations and log equations. But for exponential equation, it always works, so you don't test. You get it? Just like the normal equation. But so far we know a Sedic equation we must test. But that one we have to show our test. Log equation we must test, but we test that mentally. We don't show. Is that clear? That's the difference. And log brings in restriction. That's why we are supposed to test. Radical sign, which is the square root sign, also brings restriction. However, do you see any operation here which brings restriction in the equation? No. Okay, so in that case, when you get your values, you don't test. Automatically, they will satisfy. Okay, so now what do? We know now we are dealing with exponential equation. We are experts in solving exponential. So this would be 2x is equal to 2 to the power 1. So x will be equal to 1 here. Is that clear? Okay, and here this will give you 2x is equal to 2 to the power 0. So x will be equal to 0 here. Is that clear?
Yes.
Okay, so now you know your two values of x. You were asked just to solve, so you draw your conclusion. Therefore, okay, x is equal to the first value 1 or the second value 0. You are done. All correct. So here the point is, don't conclude with the variable that you introduce, your y. Don't conclude with your y. The equation came in x, so its solution must also be in x. Is that clear?
Yes.
Okay. All right. That will be it for the first one. Don't worry, we'll solve more today. Okay. So by the time we end the class today, you'll be well equipped. Okay. All right. So we are going to look at that of the B. Again, we are solving. So B. Okay. What are we giving? We are giving, okay, 2 to the power 2x plus 1. The whole of that is the exponent minus what? 15 into 2 to the power x. Okay, then it's equal to 8. All right, so this is what we have. Very good. So now at this point, we know per experience, the equation that we have there is likely to be in 2 to the power x equation. Okay, so take note. So once we have this, then it means any other, okay, 2 to a certain power that we see x there, any other term that contains x in the power, okay, we have to write it in this form, 2 to the power x, okay, for us to relate. And remember what we did in the comma situation. This one, we can write it like we said. If I have, immediately I see plus, I know that what I have there is the same as 2 to the power 2x, then times, okay, 2 to the power 1. Do you agree?
Yes, please.
Yes.
Okay. And we now know how to write this one. So it means this will give me 2 to the power, okay, x all squared, then times 2 to the power 1. Okay, so now that's what we are going to use. So this gives us, this implies there's an equation. So you start with implication, cannot start with equal to take note. So I am going to transform this. This first transformation will give me 2 to the power 2x, okay, times what, 2 to the power 1. Okay, then minus 15 into 2 to the power x is equal to what, 8. Okay, so at this point, I know this is 2. So, however, I can write this one also as 2 to the power x all squared. Okay, but it will be times 2. I will come and write the 2 here. Is that clear?
Yes, please.
Okay, then 15, okay, into 2 to the power x is equal to 8. Okay, so now we know, you can see that all your terms, you see 2 to the power s there, 2 to the power s there. Like s squared, s to the power 1. I'm talking about 2 to the power x, all to the power 1, to the power x. Okay, all squared to the power 2. So a quadratic into 2 to the power x. So what do you do again? You go for your substitution. So you let, okay, y be equal to 2 to the power x. Okay, Karen.
Can you change the 8 to a base
Can you
as
change
the
what?
2 because
No, it's not
the
necessary
8?
because if you change it to the base, you cannot add, you cannot multiply, you can't do anything reasonable with it.
Okay.
So in this situation,
Okay.
you are going to get a quadratic equation and it will, later you move it to that side.
Okay.
You didn't change this one to be of the same base because you realize that they are not multiplying. If they were, or if you saw multiplication here, then we could have done that because we could have used the rule. But immediately you see terms, okay, then you cannot. If you are seeing terms and you can, then it means after working on this and working on that, there will be like terms for you to add. But here, when we worked on this and that, are they like terms?
No.
Okay, so it means we can add. A square term and a linear term, they cannot never be like terms. Okay, so you carry out your substitution, then
In an exponential equation, you
come
can't
again.
add them. Whenever there are two terms in an exponential equation, you can't change the same base and add or
No, I didn't say whenever. I gave you a particular situation that you can add. Assuming maybe I give you 2 to the power x, okay, plus 1, then plus 2 to the power x. Okay, here you know that it's the same as 2 to the power x times 2 plus 2 to the power x. So this gives me 2 to the power, okay, 2 into 2 to the power 2x, that's not it. Then plus 2. So you can see that this time around they are like terms. So that one you can add. So this will give you 3 to the power, there's 3 in brackets, 2 to the power s. Do you agree? Because like terms, their variable terms are the same. Coefficient, you add this plus this, that will give you this. And I gave you a scenario before I started. But here you cannot, okay, do that. Okay, because if you simplify this in 2 to the power, you won't get this also in 2 to the power x. Okay, but it will be squared. This one it didn't give us, so they were like terms, so you can add. You can do that, but here you can't. So it requires this approach. Is that clear?
yes, please.
Okay, so now we are going to get 2y squared. Help me, minus 15y. Am I right?
Yes.
Okay, it's equal to 8, but I'm smarter. I know I'm going to solve a quadratic equation, so everything is supposed to be on one side. So I will move this one and write 8 is equal minus 8 is equal to 0. Is that clear? Or per experience, before you even started, you could have moved this one to this side because you know that you end up getting a quadratic equation and everything must be on one side. So you can move, okay, to that side at any point that you want. So here, unfortunately, this cannot be reduced. And our leading coefficient, okay, is not 1. So we have to multiply the 2 and the minus 8, which will give us what? Minus 16. So we are looking for factor pair of minus 16, which when we multiply, we get minus 16. When we add, we are going to get what? Minus 50. So factor pair, I'm waiting. Minus 16 plus what? Okay. Okay, so minus, okay, 16y plus y. Okay, minus 8 is equal to 0. Is that correct? Okay,
Yes, please.
so group the first two and factorize. 2 will come out, y will come out. So you end up getting y minus 8 here. Okay, again, plus 1 will come out, then you get y minus 8, okay, here is equal to 0. You can choose not to write a plus 1. Then you are going to get 2y plus 1 as one factor, then the other factor will be y minus 8 is equal to 0. You set each of the factor to 0, so you are going to get 2y plus 1 is equal to 0, or y minus 8 is equal to 0. So you are going to get 2y is equal to minus 1 here. You write it again before you divide. I will go to that side here. Y is equal to what? 8. So if I come here, I'm going to get 2y is equal to minus 1 again over 2. So I'm going to get y to be equal to minus 1 on 2. Is that clear? Please, have you followed up to this point?
Yes.
Okay, very good. So now look at what we have. We have the solution in terms of y. Okay, our own variable. Now the question gave us s, so we have to go and substitute back. Y has now served its purpose. So you say thank you to y and you move on. Okay, so now what do we have? Okay, we will go and write. This implies that, remember, we have y is equal to this or y is equal to that. But we said y is 2 to the power x. So you get 2 to the power x is equal to minus 1 on 2, or 2 to the power x is equal to 8. All correct?
Yes, please.
Okay. What do you think would be the value of x here? Can we write this as 2 to a certain power?
Yes, please.
Hey, where we are coming from, we just did it today. Erase.
Sir, please, since it's negative, there will be no value of x for the first one.
So what do we write?
We write no solution.
Perfect. As simple as that. Don't say anything else to. Okay, you raise what you raise whatever you said so far. All right. So as simple as that. So no solution. Remember, I told you anytime you have a number to a certain power, giving you a negative number, it will not happen. Okay, it doesn't mean so. It means I'm going to write no solution for this one. Only this one. Oh, please take notes. Not the entire. So then you come here. Here you can. So this will be 2 to the power x equal to 2. Am I right? So you get x to be equal to 3 here. So this one gave us no solution. This one gave us, 3 as a solution. So you draw your conclusion. Therefore, x is equal to what? Is that clear?
Yes.
Okay, so like I've told you, anytime I want you to apply what you've been taught, apply. So if I ask the question, then I know that you know. Okay, all right. Okay, so thank you very much for making me happy. All right, so now what do? We move on to the next one. Any question before you move on to the next one?
Mr. Hackman.
Yes, please.
Please, can you go to the previous, like this, the slide before the 3A? I want to see something there.
Okay, you are taking us back. You want to write or you want to see?
Thank you very much. I'm done.
You were writing?
No, I was seeing.
You were... Okay, so you are done seeing.
Yes, sir. Thank you very much.
You are welcome. Okay, Karen, is your hand still up?
Yes, Mr. Hackman. What if quadratic equation that cannot be factorized? Like when you factorize, we are getting.
Yes, if you cannot be factorized, that doesn't mean it cannot be solved. We encounter such a situation with the log equation. Okay, it doesn't mean it cannot be solved. If it cannot be solved, then your b squared minus 4ac should be negative. If you can solve by factorization, your b squared minus 4ac should be a perfect square. You know all these. I've told you. But if you can't solve by factorization, maybe b squared minus 4ac is not a perfect square, but it's a positive number. It only means that you cannot solve by factorization. That doesn't mean you can't solve. Okay, then when factorization fails, we have to resort to the quadratic formula or the method of completing of squares, but preferably the quadratic formula, because formulas are supposed to make our work easy or easier. Okay, as for the completing of squares, no matter how you are in love with completing of squares, unless you are restricted, don't use it. You write more. You get it? So if you can't
Is that
factor,
what you said we shouldn't use it?
I said don't use it unless you are restricted, because it's always not the ideal method. The first ideal method to solving any quadratic equation, if it's factorable, use the method of factorization, period. However, if it's not factorable, you are left with two more options: completing of squares or the quadratic formula. You agree with me?
Yes.
You have the graphical approach, but that one obviously will be out. Okay, so the two, completing of square or almighty formula or the quadratic formula. Between these two, the formula is best, because formulas are supposed to make our work easier. So if you are restricted, that's when you use the complete, because sometimes the question specifically will tell you, especially formats. Okay, using completing of squares, so that one you are restricted. If it's factorable, you can't use factorization. You are supposed to use the completing of squares. Adoma.
Mr. Hackman,
Mm-hmm.
please, I'm not saying that maybe what she has seen is just a question.
What I'm saying.
Yeah, like about the 2x is equal to -1/2. I punched in my calculator -2 to the power -1, and I had -1/2.
Which one are you talking about?
So I was the conclusion where you wrote no solution. I punched in my calculator -2 to the in my calculator. I punched -2 to the power -1.
But the 2 here is not minus. So if you are
-2 to the power -1.
Listen, if you are substituting your x, what s are you substituting?
Okay.
The coefficient of, the base here is not negative. It is positive.
Okay.
That's why I said you will not have any positive number to a particular exponent that will give you a negative result. If you can find that, okay, then come and let me fully, decorate you with your PhD or beyond, apparel. All right, okay, so that would be it. Okay, I won't pollute you. Okay, definitely. And I know my staff as well. All right, okay, so this is it. Okay, for the solution to this one. So without any further question, then I'm going to move on to the next one. Okay, anyway, this one probably is supposed to be for you. So it seems I'm done. Oh, I'm done with this one. So let's look at our next set of questions. Okay, so let's deal with the E. Okay, E is not red. This time around, you have a negative exponent. So let's look at one negative exponent, situation, how to deal with that. But indirectly, I've taught you, in the comma situation, they are only going to apply. So don't be scared. So 3. Oh, we are still looking at 3E. Okay, E. Okay, what are we giving? We are giving, 2 to the power 2x minus 3. Minus what? 2 to the power x minus what? Minus 2 is equal to what? 1. Okay, so immediately I see this. Now I'm well experienced to know that, once there is 2, s here, and there is 2 to the power x here, I'm going to get a quadratic equation because of this. If this one was not 2x and it was just x, then it means possibly I can write this as like terms. You get it? And maybe combine. Are you with me? Or I should come again. Or I should come again.
Please come again.
Okay, so assuming the question was this. 2, okay, then you have x, okay, minus 3, minus 2 to the power maybe x, okay, minus 2. Okay, I know that this is the same as what? 2 to the power x over 2 cubed. Am I right? Then minus, this will also give me 2 to the power x over 2 squared. So that indirectly will give me 1 over 8, okay, into 2 to the power x. Then this will give me 1 over 4 into 2 to the power x. So these two are like terms. So I can combine the coefficients and now attach the 2 to the power x. But here, immediately you see that the coefficient of the x here and the x here, they are not the same. It means, okay, they will not be like terms when you reduce it, okay, using the laws of log. Okay, so you have to, okay, deal with it our usual way, the way we are dealing with it. Is it clear now?
Yes, please.
Okay, so now we come and write this one as we are matured. We know that immediately we see negative between the terms. This will mean 2 to the power 2x all over 2 cubed. I hope you agree. Then,
Yes, please.
then minus, this will also give us 2 to the power x all over 2 squared is equal to 1. I'm mature, so I know I'll bring the 1 here. Okay, it's equal to 0. Is that clear? Okay, you let me keep the 1 there before somebody, okay, will be confused and later move it. Okay, the first, so let me move. Okay, so quickly, this is what I'm going to get. So it's equal to 1. Then later, I will move it when I'm simplifying. Okay, so this will give me, I know, the numerator, I can also write it as 2, okay, to the power x all squared. Okay, all over. Now I know 2 cubed is what? 8. Okay, then minus, okay, 2 to the power x, oops. Okay, all over 4 is equal to 1. Am I right? Okay, so assuming here, obviously you can see 2 to the power x. Okay, as so there, we are going to n square. So it's a quadratic into 2 to the power x. So we are going to let 2 to the power x be equal to 5. Is that clear? Or any other variable apart from x of your choice. So you write let, please, the let's start with a capital letter. And those of you who write but you are starting a sentence or a statement, you start with a capital letter, please take note. Okay, don't think because this is smart, you can write any English for us. Okay, so this is what you have. You are going to have y squared over 8. Then minus what? 2 to the power s is y, so it will be y over 4 is equal to 1. So now what do we do? If you are given this equation to solve, you clear the fraction. Is that not it?
Yes, please.
So you multiply through by the LCM, which will be what? 8. So if you, because this side contains more than a term. Okay. The LCM is 4.
No, 8.
8.
Okay. All right. Thanks for changing your mind. All right. Okay. So this is what we have. And I said, because one side contains more than a term, you can choose not to show the multiplication. You do it mentally. So this 1 times 8 give me y squared. Okay, then minus this 1 times 8, the 4 will go into the 8 too. So it will give me 2y. This 1 times 8 will give me 8. I've done the multiplication mentally. I hope you are with me. If you can't do it mentally, just show. That's okay. All right, then at this point, we know it's a quadratic equation. Everything must be on one side equated to 0. So I will bring this one here, which initially I brought and I had to take it back. So again, thankfully, leading coefficient is 1. Okay, so you have to look for factors of -8, which when you multiply, you get -8. When you add, you get what? -2. So which factor pair?
-4 plus 2.
-4, okay, y, then plus 2y, okay, -8 is equal to 0. You group first 2 and factorize y into y minus 4, last 2 and factorize 2 into y minus 4. Okay, is equal to 0. So the next step is to, okay, let me complete the factorization here. So I'm going to get y plus 2 as one factor, then y minus 4 as the other factor is equal to 0. So you set each of the factors to 0. So I'm going to get y plus 2 is equal to 0, or y minus 4 is equal to 0. So here y will be equal to minus 2. Here y will be equal to 4. Okay, so this implies that, remember y you said is 2 to the power x. So you get 2 to the power x is equal to minus 2, or 2 to the power x, which is y, is equal to 4. Okay, here this is negative. So straight away, what do we write? No solution. Is that clear?
Yes.
If it wasn't negative and it was positive, but maybe positive 3, you can't write it as same basis, then you know what to do. You have to apply the log, what we just learned. Is that clear? To solve for your x. Okay, so now what do we have? 2 to the power x. Here you can write this as a base of 2 squared. So you get x to be equal to 2. So you come and draw your conclusion. Therefore, x is equal to 2. You are done. Okay, Nenepia.
Mr. Akman, please. You see, with this one, we didn't write maybe let 2x be equal to y. Does it mean can skip it and then just make it y the whole solution?
No, we have to know where y is coming from.
Okay.
Anytime you introduce, remember I said anytime you introduce any letter, you have to define the letter. So when you write let this, then it means you are defining the letter. Is that clear?
Yes, please.
Okay, very good. All right. Okay, so that will be it for this solution. So we move on to, let me see. Okay, maybe if you can solve one question in the next set of questions. Okay, so our final set of questions, this is what we have. Maybe we'll solve it at a point A and B up to a point then. Okay, as a guide, you do, okay, the rest. Okay, all right. Okay,
Mr. Akman,
yes, please.
please can you go back to the previous slide?
Okay, who is that? What,
My name is
what are you doing there?
Akman, I want to screenshot.
Okay, all right.
Please, I'm done.
Okay, so good. All right, so now let's look at our next set of questions again. This time around, we are asked to find the solution set. So this must be underlined. Okay, so let's move on and see. Okay, so A. Okay, solution to question 4. Okay, A. Okay, again, solution sets. So what are we dealing with? Given, or you can choose not to write the given and just write 2 to the power x, okay, plus what? Okay, 2 to the power minus x. Okay, is equal to 2. All the examples that we've done so far, you realize that the x, its coefficient, okay, positive. Now the coefficient of your x is negative. Don't worry, you are more than equipped. Okay, so this will give us 2 to the power x. Okay, then plus, you know, negative exponents will give us 1 over 2 to the power x. Do you agree?
Yes, please.
Okay, it's equal to 2. So now you can see that it is what? An equation in 2 to the power x. So make it simple. Let's, okay, y be equal to 2 to the power x, or any variable apart from x. Okay, then now this implies that this is y. 2 to the power x is what? Y. So y plus 1 over y is equal to what? 2. Okay, so assuming you are given this normal equation to solve, what will you do? How would you solve it? What would be your first step?
You multiply through
By
y.
y. Very good. And this side contains more than a term, so we are going to multiply mentally. So y times y will give us y squared. All correct. Then
Yes,
plus the 1 over y times y, the y will cancel, so I will get 1. It's equal to 2 times y, 2y. Obviously a quadratic equation in y. So I will move this one to the side. So I'll get y squared followed by my y term, which I'll have to bring here to become negative 2y. Then I'll keep my 1 is equal to 0. Okay, so thankfully, okay, the factor of factors of 1 will be 1 and 1, but negative. So we are going to get what? Y squared. Look at what is going to happen here. Minus y, okay, plus 1 is equal to 0. So we are going to get, okay, first two group and factorize will give us y out, y minus what? 1. Okay, then minus 1 out, y minus 1. Last two group and factorize. Okay, so if you come here, let me complete again the factorization here. So I'm going to get y minus 1, okay, into y minus 1 is equal to 0. So let me go the usual direction. You set each of the factors to 0. They are repeated factors anyway. Someone can write squared here and later go and take the square roots. Okay, but I am not doing that. I'm going the usual direction. So I'm going to get y minus 1 is equal to 0, or y minus 1 is equal to 0. That will give me y is equal to 1 here, also y is equal to 1. So this time around, you have a repeated root. Am I right?
Yes, please.
Okay, so when you have a repeated root, you have to discard 1. So this implies that y is equal to 1. Because they will all give you the same result. So just use one of them. Is that clear?
Yes.
So now you are going to write, this implies that y you said is what? 2 to the power x. So I will get 2 to the power x is equal to what? 1, which will give me 2 to the power x is equal to 2 to the power 0. So x is equal to 0. However, I was asked to find a solution. So therefore, okay, s is such that x is equal to what? 0. And I close it. Point well made.
Yes.
Yes.
Okay, very good. All right, so now let's see what will happen here. And let's substitute and see. Okay, 2 to the power 0 is what? 1. 2 to the power minus 0, 0 doesn't have negative, so just the same as 0. So 1. So you get 1 plus 1, which is equal to 2. But I've told you it is not your business to check. In this situation, provided you do the right thing, they will always satisfy because no constraints, no restriction on your variable or variables. Is that clear? Okay.
Yes, please.
Okay, so now let me see whether time will allow for one question. Oops. Okay, I wanted a situation where so far it's like we are doing okay 2 to a certain power. With this one, I'll only help you break it down. At a point where you do your substitution, okay, you should be able to do it and continue from there. So let's look at the C, and that will be it for today. Quickly look at the C. What are we giving? We are giving 3 to the power 2x minus what? 3. Okay, minus 4 into 3 to the power x minus 2. Okay, plus 1 is equal to 0. So again, we are mature. Now we know that this will give us, okay, straight away, I'll write this one as 3 to the power x all squared all over what? 3 cubed. Do you agree?
Yes, please.
Okay, then minus, okay, my bracket here will give me 4 into the bracket will give me 3 to the power x all over, okay, 3 squared. Do you agree?
Yes, please.
Then plus 1 is equal to 0. So now that the 3 to the powers that I can get, I'm going to get it before I carry out my substitution. So I'll get 3 to the power x all squared over 27. Am I right? Minus 4, okay, over 9 into 3 to the power x plus 1 is equal to 0. Do you agree?
Yes.
Okay,
Yes,
this will give you 3 to the power x over 9, but the constant you know. So 4 over 9, then you keep this. At this point, you carry out your substitution. So let's, okay, y be equal to what? This time, right, to be 3 to the power x. So what do you mean? This implies that y squared over 27, okay, minus 4 over 9. 3 to the power s is y. So y plus 1 is equal to 0. So what do? You multiply through by the LCM. Okay, then you proceed from here. However, your solution, first of all, will be in terms of y. So when you get the value, then you come and write, this implies that 3 to the power x, okay, is equal to that value. and you check if you can solve that resultant, okay, exponential equation. All correct?
Yes, ma'am.
Okay, so you will continue from here. Okay, maybe the recorded version that will be sent. Okay, you have, okay, the entire solution there, but you should be able to
Mr.
proceed from
Hartman,
here. Yes, please.
please can you come over the second step again before the let y be equal to 2x?
This one.
Yes, please.
Oh, do you get the first step?
Yes, I get the first step.
Okay, so 3 cube is what?
27.
Okay, if you like, you can also write this as 4 in brackets, 3 to the power x over 3 squared is what?
9.
So you can write this, okay, the brackets can take the whole of your fraction, 3 to the power x over 9. Okay, I decided to bring the 9 here because they are alike.
Okay.
So 4 and what? You
Okay.
get it? So it's the same thing, the plus
Yes.
one, let me clear. Okay, so this will be your
Okay.
assignment. Okay, this is going to be your assignment. It's because of the assignment that I taught you the 3 solution. Okay, you need it. It's similar to what we just did. You can see that. Very similar. Okay, all right. So hello, Eresi.
Mr. Hackman,
Yes,
please,
please.
I'm a little bit confused.
A little
Today,
bit.
yes, today did we do commerce or e-maths?
Elective maths.
I thought we're learning what's the name? Partial fractions in elective maths.
You joined late, right?
No, sir, I joined on time.
You joined on time. You remember
Yes.
I said before I said that we are supposed to partial fraction. I sent you the last video. Only that I
Yes.
gave you an let me. Okay, we are done with today's lesson. Okay, we thank God for today's lesson. Okay,